Hello, thank you for watching this video on arc flash safety for electrical workers. We're going to cover one of the most critical safety topics in the electrical industry, arc flash hazards and how to protect ourselves from them. This video will focus on three key areas: understanding arc flash hazards, selecting proper flame-resistant clothing, and implementing effective access control through arc flash boundaries. Before we begin, I want to emphasize that arc flash safety isn't just about compliance, it's about going home safely to your families every day. The information we'll cover today could literally save your life or the life of a co-worker. Let me start with a sobering statistic that underscores why we're here today. According to OSHA, arc flash incidents cause approximately 2,000 burn injuries per year that require hospitalization. Even more concerning, 80% of electrical worker fatalities result from burns, not shock. These numbers aren't just statistics, they represent real people, real families, and real tragedies that are largely preventable. This video will cover four critical areas. First, we'll explore arc flash hazards, what they are, how they occur, and why they're so dangerous. Understanding the enemy is the first step in defeating it. Second, we'll discuss flame-resistant clothing selection, how to choose the right protection for your specific work environment and tasks. Third, we'll examine arc flash boundaries, how they're established and why they're crucial for your safety. Finally, we'll cover access control implementation, the practical steps you need to take to protect yourself and your team. By the end of this video, you'll have the knowledge and tools to work more safely around electrical hazards. So, what exactly is an arc flash? An arc flash is a type of electrical explosion that results from a low impedance connection through air to ground or another voltage phase in an electrical system. Think of it as an electrical short circuit that occurs through the air rather than through a conductor. Let me put the severity of this hazard into perspective. An arc flash can reach temperatures of up to 35,000 degrees Fahrenheit, that's 19,400 degrees Celsius. To give you a comparison, that's nearly 4 times hotter than the surface of the sun. At these temperatures, copper conductors vaporize instantly, creating an explosive blast of superheated gas and molten metal. The image you see here shows the devastating power of an arc flash event. Notice the intense light, the explosive force, and the amount of energy being released. This isn't a slow developing hazard. Arc flash incidents occur in less than 1/10 of a second, but the consequences can last a lifetime. What makes arc flash particularly dangerous is that it combines multiple hazards simultaneously: extreme heat that can cause severe burns even at a distance, intense light that can cause permanent eye damage, and an explosive pressure wave that can throw workers across a room and cause serious physical trauma. Now let's examine the specific hazards that make arc flash incidents so dangerous. Understanding these hazards will help you appreciate why proper protection is so critical. First, extreme heat. As I mentioned, temperatures can reach 19,400 degrees Celsius. This heat can cause severe burns even if you're several feet away from the arc source. The heat energy travels at the speed of light, giving you no time to react or escape once an incident begins. Second, intense light. The ultraviolet and infrared radiation produced by an arc flash can cause temporary or permanent blindness. Workers have reported being temporarily blinded by arc flash events occurring in adjacent rooms, even when they weren't directly exposed to the arc. Third, the pressure wave or arc blast. This explosive force can reach pressures of over 2,000 pounds per square foot. This pressure wave can throw workers across rooms, cause them to fall from heights, rupture eardrums, and cause serious internal injuries from the concussive force. Fourth, molten metal. The extreme heat vaporizes and melts metal components, creating a shower of molten copper, aluminum, or steel that can cause severe burns and embed in skin and clothing. Fifth, toxic fumes. The vaporization of materials releases hazardous fumes and gases that can cause respiratory problems and other health issues. Finally, hearing damage. Arc flash events produce sound levels exceeding 140 decibels, that's louder than a gunshot and can cause immediate and permanent hearing loss. Remember, these hazards can affect you even if you're not the person working on the equipment. Arc flash injuries can occur to anyone within the arc flash boundary. Understanding what causes arc flash incidents is crucial for prevention. Research by the IEEE Industry Applications Society has identified the primary causes: and I want to share these statistics with you because they reveal where we need to focus our prevention efforts. Human error accounts for 38% of arc flash incidents. This includes accidental contact with energized parts, dropping tools or conductive materials into electrical equipment, following incorrect work procedures, and failing to use proper personal protective equipment. The good news is that human error is preventable through proper training, procedures, and awareness. Faulty equipment causes 24% of incidents. This includes damaged insulation, loose connections, exposed lift parts, and general equipment failure. Regular maintenance and inspection programs are critical for identifying and correcting these issues before they lead to an incident. Dust and contaminants account for 22% of incidents. Conductive dust accumulation, moisture or water ingress, corrosion creating conductive paths, and foreign objects and electrical equipment can all create conditions that lead to arc flash. This is why housekeeping and environmental controls are so important in electrical work areas. Improper maintenance causes 16% of incidents. This includes lack of regular inspection, deferred maintenance, incorrect parts replacement, and inadequate testing after maintenance work. A robust maintenance program isn't just about equipment reliability, it's about safety. What's important to note is that most of these causes are preventable. With proper procedures, training, and maintenance, we can significantly reduce the risk of arc flash incidents. Prevention is always better than protection, and when it comes to arc flash, we follow the hierarchy of controls, moving from the most effective to the least effective methods. At the top of our hierarchy is elimination, de-energizing equipment. This is the safest approach and should always be your first choice when possible. Working on de-energized equipment following proper lockout/tagout procedures eliminates the arc flash hazard entirely. Remember, dead circuits don't arc. Next are engineering controls, such as arc-resistant equipment. This equipment is designed to contain arc flash energy and direct it away from personnel. While this doesn't eliminate the hazard, it significantly reduces the risk to workers. Administrative controls include safe work practices, procedures, training, and permits. These controls rely on people following procedures correctly, which is why training and reinforcement are so critical. Finally, we have personal protective equipment or PPE. While PPE is essential when other controls aren't sufficient, it's important to remember that it's the last line of defense, not the first. Essential prevention steps include conducting arc flash hazard analyses to determine incident energy levels and boundaries, properly labeling equipment with arc flash warnings, maintaining regular inspection and maintenance schedules, and ensuring all electrical workers receive proper training on arc flash hazards. The key message here is that prevention requires a systematic approach. It's not enough to just wear PPE, we need to implement all levels of the hierarchy to effectively manage arc flash risks. Now let's turn our attention to flame-resistant clothing, or FRC. When other controls aren't sufficient to eliminate the arc flash hazard, proper FRC becomes your lifeline. Flame-resistant clothing is specially designed to self-extinguish once the source of ignition is removed. This prevents continued burning and significantly reduces the severity of burn injuries. Why is FRC so critical for electrical workers? First, it provides thermal protection against arc flash heat, creating a barrier between the intense heat energy and your skin. Second, it reduces burn injury severity and extent. Studies have shown that proper FRC can mean the difference between minor burns and life-threatening injuries. Third, it provides critical escape time during an incident, allowing you to get away from the hazard source. Finally, it's required by OSHA and NFPA 70E standards, it's not optional. Here's a critical point I want to emphasize: regular clothing can actually make arc flash injuries worse. Cotton and other natural fibers can ignite and continue to burn, while synthetic materials like polyester and nylon can melt onto your skin, causing severe burns that are extremely difficult to treat. This is why wearing the right clothing isn't just about compliance, it's about survival. Remember, most arc flash burn injuries are actually caused by clothing igniting and continuing to burn, not from the arc flash itself. Proper FRC prevents this secondary burning, which is often more severe than the initial thermal exposure. Selecting the right flame-resistant clothing isn't as simple as just buying any FRC. There are several critical factors you need to consider to ensure you have the right protection for your specific work environment. The most important factor is the arc rating, expressed as either ATPV, arc thermal performance value, or EBT, energy break-open threshold. The arc rating indicates the maximum incident energy in calories per square centimeter that the fabric can withstand before a second-degree burn occurs. Your FRC must have an arc rating equal to or greater than the calculated incident energy level for your work task. Next is the hazard risk category or HRC, as defined by NFPA 70E. The standard categorizes electrical hazards into different HRCs, each requiring a minimum arc rating. HRC 1 requires 4 calories per square centimeter, HRC 2 requires 8 calories per square centimeter, HRC 3 requires 25 calories per square centimeter, and HRC 4 requires 40 calories per square centimeter. Layering is another important consideration. Wearing multiple layers of FRC can increase the overall arc rating, but there's a critical warning here: non-FR undergarments can melt and cause severe burns. If you're layering, everything that touches your skin must be flame resistant. Fit and comfort are also crucial. FRC should fit properly to allow for ease of movement and prevent snagging. Comfortable FRC is more likely to be worn consistently, and consistency is key to safety. Finally, there are prohibited materials you must avoid. Synthetic materials like nylon, polyester, rayon, and acetate can melt onto the skin when exposed to heat, causing severe burns. These materials should never be worn as outer layers or undergarments when arc flash hazards are present. Now let's walk through the step-by-step process for selecting proper flame-resistant clothing. This systematic approach ensures you get the right protection for your specific work environment. Step 1. Conduct an arc flash hazard analysis. This engineering study determines the incident energy and arc flash boundary for each piece of equipment and each task you'll be performing. Without this analysis, you're essentially guessing at what protection you need. Step 2. Determine the required arc rating. Based on the incident energy calculated in Step 1, select FRC with an arc rating equal to or greater than the calculated value. Never select FRC with a lower arc rating than required, it won't provide adequate protection. Step 3. Consider layering. If higher arc ratings are needed than what's available in a single garment, consider layering multiple FRC items appropriately. Remember, all layers must be flame resistant. Step 4. Ensure proper fit and comfort. Select FRC that allows for safe and comfortable work. Ill-fitting clothing can be a safety hazard in itself, and uncomfortable clothing is less likely to be worn consistently. Step 5. Verify compliance. Ensure all FRC meets applicable safety standards including NFPA 70E, ASTM F1506, and OSHA regulations. The Standards Compliance section shows the key standards you need to be familiar with. NFPA 70E is the standard for electrical safety in the workplace. ASTM F1506 covers arc-rated clothing specifically, and OSHA 1910.269 covers electric power generation, transmission, and distribution. Don't forget about FRC care and maintenance. Follow manufacturer's washing instructions, inspect regularly for damage or contamination, replace damaged or worn FRC immediately, and never use fabric softeners or bleach, as these can reduce the flame-resistant properties. Now let's discuss the arc flash boundary, which is a critical concept for establishing safe work practices around electrical equipment. The arc flash boundary is defined as the minimum safe distance from energized electrical equipment where a worker could suffer a second-degree burn from an arc flash event. Specifically, it's set at the distance where the incident energy equals 1.2 calories per square centimeter. The diagram you see here illustrates how the arc flash boundary is established around electrical equipment. Notice how the boundary creates a zone where special precautions are required. Here are the key points about the arc flash boundary. First, it's set at 1.2 calories/cm because this is the threshold for a second-degree burn, the point where permanent injury begins to occur. Second, any worker within this boundary must wear appropriate PPE rated for the incident energy level at their working distance. Third, the boundary is determined through an arc flash hazard analysis, which calculates the incident energy at various distances from the equipment. Finally, the distance varies significantly based on equipment type, voltage level, and available fault current. It's crucial to understand that the arc flash boundary is specifically for protection against thermal hazards from arc flash, not electrical shock. This is a common misconception. The arc flash boundary and shock protection boundaries serve different purposes and are calculated differently. The arc flash boundary isn't a fixed distance, it's specific to each piece of equipment and must be calculated based on the electrical characteristics of that equipment and the system it's connected to. Establishing the arc flash boundary is only the first step. Implementing effective access control is what actually protects workers. Let me walk you through the key components of effective access control. Warning signs and labels are your first line of defense. Equipment likely to cause an arc flash must be clearly labeled with arc flash warnings. These labels must indicate the incident energy level, specify the required PPE, and show the arc flash boundary distance. The labels serve as a constant reminder of the hazards present and the precautions required. Barricades and ropes provide physical barriers to delineate the arc flash boundary and prevent accidental entry by unauthorized personnel. Use safety tape with appropriate warnings, and ensure barriers are placed at the calculated boundary distance. Physical barriers are especially important in areas where multiple workers or contractors may be present. Access control means that only trained personnel should be allowed within the arc flash boundary. These workers must wear appropriate PPE for the hazard level, understand arc flash risks and safety procedures, and be authorized to perform the specific work being conducted. Job briefings are essential before any work begins within an arc flash boundary. These briefings should cover the specific arc flash hazards present, review the boundaries and required PPE, verify that appropriate PPE is available and being worn correctly, and discuss emergency procedures in case an incident occurs. Finally, continuous monitoring ensures that the arc flash boundary is respected throughout the work activity. The boundary should be continuously monitored to ensure compliance and adjusted as necessary when conditions change. For high-risk tasks, a designated safety observer may be required to watch for unsafe conditions and ensure procedures are being followed. Remember, access control isn't just about keeping people out, it's about ensuring that those who need to enter are properly protected and prepared. It's important to understand that the arc flash boundary is just one of several boundaries defined by NFPA 70E for electrical safety. Each boundary serves a different purpose and protects against different hazards. Let's look at this comparison table. The arc flash boundary, which we've been discussing, protects against thermal burns from heat energy and allows entry only by qualified persons with appropriate PPE. The limited approach boundary protects against shock hazards from electrical contact. Qualified persons can enter this boundary, and unqualified persons can enter with a qualified escort. The restricted approach boundary provides increased protection against shock hazards where there's an increased risk of electrical contact. Only qualified persons with appropriate PPE can enter this boundary. There used to be a prohibited approach boundary that prevented direct contact with live parts, but this was removed from NFPA 70E in the 2015 edition, though some organizations may still reference it. The key differences to remember are, the arc flash boundary is for thermal protection, while limited and restricted boundaries are for shock protection. Different boundaries may require different types of PPE. The boundaries are calculated separately based on different criteria, and may result in different distances from the same equipment. Important considerations include always identifying all applicable boundaries for your work, using the most conservative boundary for access control when multiple boundaries apply, recognizing that different work tasks may have different boundary requirements, and understanding that boundaries must be recalculated when system changes occur. Don't assume that one boundary covers all hazards. You need to consider both arc flash and shock protection boundaries for comprehensive safety. As we wrap up today's presentation, let me summarize the key takeaways that I want you to remember and apply in your daily work. First, arc flash awareness. Arc flash incidents can cause severe injuries or death, but they are preventable with proper safety measures and awareness. The statistics we discussed aren't inevitable, they represent failures in our safety systems that we can and must prevent. Second, proper FRC selection. Selecting appropriate flame-resistant clothing based on incident energy levels is critical for worker protection during an arc flash event. This isn't about wearing any FRC, it's about wearing the right FRC for your specific hazards. Third, boundary establishment. Properly establishing and marking arc flash boundaries helps prevent unauthorized access to hazardous areas and ensures appropriate PPE usage. Boundaries aren't suggestions, they're life-saving barriers that must be respected. Fourth, continuous training. Regular training and refresher courses ensure workers maintain awareness of arc flash hazards and proper safety procedures. Safety knowledge isn't permanent, it requires constant reinforcement and updating. Here's my final message to you: arc flash safety is not optional. It's a critical component of electrical safety that saves lives. Always follow proper procedures, wear appropriate PPE, and respect established boundaries. I want each of you to make a personal commitment today to apply what you've learned. Your family is counting on you to come home safely every day, and your co-workers are counting on you to work safely so you don't put them at risk. Remember, the difference between a safe act and an unsafe act is knowledge and training. You now have the knowledge, it's up to you to apply it consistently. Thank you for watching this video and for your commitment to electrical safety.